Hello guys, in this class we will see how glycol can be converted to ethene, oxyrin, ethanol, dinitroglycol, 1,4 dioxane, formaldehyde. Okay, the structure of glycol will be CH2OH, CH2OH. Okay, and also we are going to see how glycerol can be converted to acrolein and nitroglycerin. Okay, glycerol structure will be CH2OH, CHOH and CH2OH. Alright, it's a triol and glycol is a diol. Okay, normally it is called as ethylene glycol. Alright, CH2OH, CH2OH. First, let us see how ethene can be prepared from glycol. Ethene வந்து glycol வந்து எப்படி prepare ஆகுது அப்படின்ட்டு first பார்க்கலாம். Alright, so this is actually given in the chapter Hydroxy compounds and esters. Plus 2 book, second volume. So glycol, CH2OH, CH2OH. Okay, so if it is treated with PI3, phosphorus iodide, or hydroiodic acid, just HI. Okay, so whatever may be. Alright, so what will happen is in the place of OH group, iodine will get substituted. சரியா, so CH2OH, CH2OH இருந்து ethylene, அதாவது CH2 double bond CH2 வரணும்னா இந்த ரெண்டு OH நம்ம ரிமூவ் பண்ணி ஆகணும். ஓகே, அப்போ நம்ம PI3யோட ரியாக்ட் பண்ணால் இந்த ஒரு OHல இருந்தும் OHலையும் வந்து அயோடின் வந்து சப்ஸ்டியூட் ஆகும். ஸோ யூல் கெட் அன் இன்டர்மீடியட் லைக் திஸ் 1,2 டைஅயோடோ ஈத்தேன். இது வந்து ஹைலி அன்ஸ்டேபிள், ஏன்னா அயோடின் வந்து பெருசாக இருக்கும் சைஸை. ஸோ அதனால் வந்து இது வந்து அன்ஸ்டேபிளாக இருக்கும். ஸோ தென் ஃப்ரம் திஸ் அயோடின் மாலிக்யூல் வில் கெட் ரிமூவ்டு. ஓகே, I2 ரிமூவ் ஆகிடும். அதுக்கப்புறம் என்ன இருக்கும் உங்களுக்கு மிச்சம்? CH2 double bond CH2, ethene. Ethene is also known as ethylene. Okay, so very simple reaction. உங்களுக்கு வந்து glycol வந்து ethylene வரணும்னா ரெண்டு OH ரிமூவ் பண்ணணும். அப்போ அயோடின் சப்ஸ்டியூட் ஆகணும். அயோடின் சப்ஸ்டியூட் ஆகணும்னா HIO இல்லை PI3. ஓகே, we are going to react it with. இப்போ ரியாக்ட் பண்ணும்போது in the place of OH iodine will get substituted. So highly unstable intermediate. Okay, and then from this iodine will be liberated, leaving ethylene, CH2 double bond CH2, which is also known as ethene. Alright, so next we will see how glycol can be converted to oxyrin. Glycol to oxyrin, yeah. So oxyrin, how oxyrin will be CH2 CH2O. This is oxyrin. 1,2 epoxy ethene. Okay, so we should bring this one oxyrin from glycol. Okay, then see what we have to remove. We have to remove water molecules. Okay, very simple reaction. Just heat it, 773 Kelvin. Alright, you get oxyrin because water molecule will get removed. CH2 CH2O, oxyrin is also called as 1,2 epoxy ethene. Okay, so we finished two reactions. Next we will see how glycol converted to ethanol. Glycol to ethanol. What is ethanol? Ethanol is nothing but acetaldehyde. Okay, so it has got 2 carbon in it. Aldehyde group is there. Okay, so this is nothing but acetaldehyde or ethanol. It's an aldehyde, right? From ethane, just remove E and then write A, ethanol. Okay, you should get acetaldehyde or ethanol from glycol. Alright, so here again H2O has to be removed, but this time OH from here and H from here will be removed. Okay, this can be done by treating it with zinc chloride. So let me write the remaining product. CH2 after removal of water, CH2 double bond will come here. Okay, double bond, one hydrogen is removed, right? So CH and then this OH. This is nothing but vinyl alcohol. So this is the intermediate now, intermediate product. Then from vinyl alcohol, you get acetaldehyde or ethanol. On tautomerization. Okay. Only the hydrogen from here will shift to this carbon atom, and this bond will shift over here. So we get CH3 and then CHO, or you can also write C double bond O and H. So like this also you can write, or else you can just write CH3 CHO itself. Okay, so it's a simple reaction. To get ethanol, water molecule has to be removed. Okay, but OH from here and H from this carbon atom. So this can be done by treating it with the zinc chloride. You get vinyl chloride as an intermediate product, and that on tautomerization. Okay, hydrogen from the OH group shift to the CH2 group. You get acetaldehyde. Acetaldehyde, simply if you want you can write like this also, like CH3 CHO itself. So acetaldehyde, also called as ethanol. Ethanol is the IUPAC name. Okay, common name is acetaldehyde. So now you know how to convert glycol to ethene, glycol to oxyrin, glycol to ethanol. Next, dinitroglycol. Very, very simple. Glycol has to be treated with a concentrated nitric acid and concentrated sulfuric acid. Nitration occurs. Only this H will be substituted by NO2. CH2O, H is substituted by NO2. Dinitro glycol. Okay, what is left now? To prepare 1,4 dioxane and formaldehyde from a glycol. To prepare 1,4 dioxane, write 2 molecules of glycol in the linear form. This is one glycol. This is another glycol. This is very, very simple reaction. Okay, treated with the sulfuric acid, which is concentrated. 2 molecules of water removed. Okay, so the 1,4 dioxane can be written like this: oxygen. It's very, very simple reaction. Okay, 1,4 dioxane. Next, let's see how glycol can be converted to formaldehyde. What's the formula for formaldehyde? HCHO. HCHO is the formula for formaldehyde. Glycol treated with the periodic acid, HiO4, followed by hydrolysis in the presence of H+. Periodic acid. Okay, first cyclic periodate ester is formed as an intermediate. How to write that we will see. CH2 OO, iodine. Okay, double bond O, OH. What is this? Cyclic iodate ester, unstable one. Okay, so this one will form an formaldehyde. This group will form another formaldehyde. So bond breaks here. So this is one formaldehyde, this is another formaldehyde. I can just write 2 molecules of CHO or CHO, HCHO, HCHO. Okay. So I am writing 2 molecules of HCHO from these two plus HiO3. Okay guys, so from ethylene glycol, okay, on treatment with periodic acid, we get an intermediate cyclic periodate ester. Just you should know how to write this intermediate, okay, and then from this undergoes decomposition to form 2 formaldehyde, HCHO and HiO3. That's it. So we have seen how to convert glycol to ethene. Okay, so glycol to ethene, what do you have to do? We have to remove 2 OH groups, right? So we have to treat it with the Pi3. Oxyrin, we have to remove water molecule. Okay, so just on heating, oxyrin can be produced. Ethanol means acetaldehyde. Okay, so you should get CH3CHO. Here also one water molecule has to be removed, but OH from here and H from here will be removed. So it has to be treated with the zinc chloride. Dinitroglycol with the concentrated nitric acid and sulfuric acid. The H alone will get substituted by NO2. And 1,4 dioxane. Okay. Then we have to write this in the linear form and treat it with sulfuric acid. 2 molecules of water will be removed to form 1,4 dioxane. Formaldehyde, to get formaldehyde, that is HCHO, treat it with the periodic acid. Cyclic periodic ester will be formed as an intermediate. Okay, that's it. So next we will see how acrolein and nitroglycerin can be prepared from glycerol. Prepare acrolein from glycerol. It has to be heated with the KHSO4, which is a dehydrating agent, or it can also be treated with the concentrated sulfuric acid. That is also dehydrating agent. Dehydrating agent means water can be removed. Okay, so water is removed from this also like this. Okay, then what is formed? CH2 double bond, only CH remaining here, CH here, CHO, which is an aldehyde. This is acrolein. Also called as 3 carbon atoms are there. Pro 2 in second carbon double bond is there, so 2 ene, it's an aldehyde, so Al. Pro 2 ene Al. Next, from glycerol to 1,3 trinitroxy propene or nitroglycerin. Okay, that we will see now. This is a very simple reaction treated with concentrated nitric acid, concentrated sulfuric acid. All these 3 hydrogen will be substituted by NO2. That's it. ONO2, then ONO2. Only hydrogen is substituted by NO2. What is this? Trinitroglycerin. Okay, TNG, or 1,2,3 trinitroxy. 3 carbons are there, right? Propane. Okay guys, So in today's class we have seen how ethene, oxyrin, ethanol, dinitroglycol, 1,4-dioxane formaldehyde can be prepared from glycol, and acrolein and nitroglycerin, how it can be prepared from glycerol. Okay, hope you understood. Meet you all in the next class.